In this video, we will be discussing section 12.1, which begins on page 794 of your textbook, and the title of this section is Explore Solids. So let's go ahead and look at our first couple of definitions. A polyhedron is a solid that is bounded by polygons. So remember the three requirements in order to be a polygon were closed, the sides must be straight sides, so no curves, and it must have greater than or equal to 3 sides. Alright, so each of those solids are called faces, so we are not going to call them sides, we are going to call them faces. And they enclose a single region of space. An edge of a polyhedron is a line segment formed by the intersection of two faces. So as you remember, two planes intersect at a line, and a vertex of a polyhedron is a point where 3 or more edges meet. Alright, so that's going to be where a couple, more than 2 faces are meeting, more than 2 planes are meeting at a point. So the plural of polyhedron is either polyhedra or polyhedrons. Okay, looking at a couple of examples here, we have a polyhedron here that is called a prism, alright, and then I also have a pyramid, and then the non-polyhedrons, notice how they all have curves of some sort. So classifying them, of the 5 solids above in your textbook, the prism and the pyramid are polyhedra. To name a prism or a pyramid, use the shape of the base. So here it is a pentagonal prism, so we use the shape of the base. It is a pentagon, and then we just say prism after it. And then to name a pyramid is the exact same. Alright, the base shape is a triangle, so it is a triangular pyramid. So you could have a pentagonal pyramid, you could have a square pyramid, or a rectangular pyramid. You could have a hexagonal prism. Alright, it just depends on what the shape of the base is. So that is how you name it. Shape of the base, and then either a prism or pyramid. And in order to determine whether it is a prism or a pyramid only has one base, and a prism is going to have 2 parallel bases. 2 parallel bases. Alright, those faces that are the bases are completely parallel. Now, you might have a cube or rectangular prism where you get to choose your base. Here, in this pentagonal prism, the 2 pentagons are congruent, and they're the only faces that are parallel, so those are the bases. Alright, so looking at example 1, tell whether the solid is a polyhedron. If so, name it, and find the number of faces and vertices and edges. So you're going to have to count. So here are parts A and B. Alright, the solid is, for part A, the solid is formed by polygons, so it is a polyhedron. So looking back at this, part A is a polyhedron, and 2 bases are congruent. They are rectangles, so it doesn't matter whether I'm talking about this one or this one to be my base, or the left or the right face to be my base, or the top or the bottom. Regardless, they are rectangles, so it's going to be a rectangular prism. And counting it all up, it has 6 faces, 8 vertices, and 12 edges. Part B, looking back at it, it is a pyramid. Alright, so looking back, it is a pyramid, and the shape of the base there is a hexagon, so it's a hexagonal pyramid. 7 faces, 1 base, and 3 triangular faces, and then 3 of them are not visible, as they would be behind. That's why they draw it with a dashed line. And C is a cone. It has a curved surface, so it is not a polyhedron. Alright, so why don't you go ahead, pause the video, and try out these guided practice, and then some solutions will pop up. Alright, so moving on to Theorem 12.1, our first theorem of Chapter 12, Euler's theorem. So we pronounce it like Euler. Alright, Euler's theorem says the number of faces f, the number of vertices v, and the number of edges of a polygon have a relationship. Alright, and there is a formula. F plus V equals E plus 2. So if you're finding it difficult to count all of the edges or vertices or faces, especially if they're not visible, which means they're drawn with those dashed lines, it can be really difficult, so we can use this formula instead. So in example 2 here, we have house construction. Find the number of edges on the frame of the house. And the frame has 1 face as its foundation, 4 that make up the walls, and 2 that make up the roof, for a total of 7 faces. Finding the number of vertices, so we're looking at all the intersection points here. Alright, so there's 1, there's 2, there's 3, 4, the same number around the base, or the foundation, and then we've got 2 more for the roof here, the peak of the roof. So the frame has 10 vertices, and using Euler's theorem, which it can be really difficult off of that picture, so substituting in those values, I get f plus v equals e plus 2, 7 plus 10 equals e plus 2, and the number of edges, 15. Alright, so talking about regular polyhedra, if you guys had ever noticed, there is a regular polyhedron that sits on top of my desk. I also have some examples, so when we return to class, you guys can play with those physical blocks. You guys can probably very easily find a cube around your house somewhere, but the other ones might be difficult. So a polyhedron is regular if all of the faces are congruent regular polygons. A polyhedron is convex if any 2 points on its surface can be connected by a segment that lies entirely inside or on the polyhedron. And if the segment goes outside of the polyhedron, it is non-convex. So they picked a point on one of the sides here, and so they picked this point and they picked another point and they drew a line here, and this line is not contained entirely on that side or that face, because as you can see, it kind of dips in there. It is concave, and it is definitely not regular. Alright, so looking at the 5 regular polyhedron, they are called platonic solids after Plato. And we've got a regular tetrahedron. Tetra stands for 4, so it has 4 faces. You have a cube with 6 faces, a regular octahedron, octa 8, and dodecahedron. Do is going to be 2, deca is 10, so that's 12 faces. And then an icosahedron has 20 faces, in which they are all regular acute triangles. So there are only 5 of them, and you can read the explanation as to why. And here are some pretty cool pictures of those, just drawing them in color versus black and white, and then these are called nets. Alright, so if you were to print those out, you should be able to fold them up and create an icosahedron or a tetrahedron or a cube. So looking at example 3, Euler's theorem, actually fully utilizing Euler's theorem here. The number of faces and vertices for a regular octahedron, find the number. By counting, you can find that the octahedron has 8 faces, 6 edges, or 8 faces, 6 vertices, and 12 edges. Using Euler's theorem to check, f plus v equals e plus 2, 8 plus 6 equals 12 plus 2, and 14 equals 14. Since it is a true statement, the solution checks out. Alright, and do keep in mind that sometimes counting these edges or these vertices in the back here for the non-visible sides can be difficult. Okay, our last part of this section is a cross-section. Imagine a plane slicing through a solid, so you can think of a block of cheese, or you can think of a watermelon when you chop it in half. What do you see? That is called a cross-section. The intersection of a plane and a solid is called the cross-section, and you can see to the right where the plane intersects that triangular pyramid. The cross-section of where it cuts it is a triangle, and it's not always the case that the cross-section is going to be the same shape as the base. So describe the shape formed by the intersection of the plane and the cube. Alright, so part A here, the cross-section is still a square. It looks like that plane is parallel to a base. But then part B looks a little bit different. Part B, the cross-section is a rectangle. Alright, in example 4, C here, the cross-section is going to be a trapezoid because it intersects it at more of an angle. It's not parallel, and it's not slicing from vertex to vertex. So why don't you guys try guided practice number 4. Alright, so if you use Euler's theorem, and if you're able to completely count all of the faces, vertices, and edges, you should have come out to 32 on each side. And then guided practice number 5. Guided practice 6. And 7. Alright, if you guys have any questions, always feel free to send me an email or a message on Google Classroom. Good luck!